So we are discussing about the collection frameworks in Java. So yesterday we have completed the array list concept. Okay. I hope my voice is clear and my screen is visible, isn't it? Yes, no? Can you please confirm on this? Are we good to start? Okay. Okay, Jyoti. Okay. So we have completed discussing about array list, and these are the points that we have taken. Okay, all these points are justified, and we have also spoken about the syntax of array list. Could be non-generic type and it could be generic type, right? And these are the methods that we have in the array list. Yes or no? We have add method, we have size method. Okay, and there are so many methods. So these are the very much significant methods. Okay, you use these methods very often. Okay, so we have discussed totally about 11 methods. So I have concluded that the concept of array list is completed, and I've also given you the internal data structure. Okay. So today the topic is going to be what? The linked list in Java. Linked list. Okay. So whenever you are getting a query in the interview room, okay, about any classes, any such classes, okay. For example, so we are discussing about these topics. Okay, so we have completed discussing about the array list. Okay, now today we are going to discuss about linked list. Okay, so when you get a question like what is a linked list, ideally when you get a question in the interview like what is a linked list, by looking at this diagram, you can add 3 points here. Okay, what is the first point that you can add here? Okay, the linked list implements the list interface. Okay, let me remind you once again for the last time. Okay, this is the interface. Let me put it in black. Okay, list is an interface. Okay, and the array list is a class, and linked list also a class, and this is a class, and this is a class. Okay, when you get a question about what is a linked list, okay, you have an answer already. You have an answer. You can say that linked list is a class which implements the list interface. Can I say that? Can't I say that? Right? So ideally we have what? We have the linked list which is implementing the list interface. Linked list is a class which is implementing what? Which is implementing the list interface. Right? You got one answer already. Okay, so first point can be what? The linked list. Okay, the linked list is a class. It's a class which implements list interface. Okay, second point is you can add this point as an add-on. Okay, it was introduced in the JDK Java Development Kit 1.2 version. JDK 1.2. Yeah, this is the second point you can add. Okay, just go back to the array list points and just collect some data, and you can also add this. Okay, you can also add this, and you can also add this. Okay, first 4 points are in your hands. Okay, it is a class in the Java collection framework. I can take that point here also because that point is applicable to linked list also. Okay, and the fourth point is what? What do we have in the fourth point? Okay, array list is a array list. Here it says array list is in java.util package. Of course, if array list is in java.util package, the linked list is also in java.util package. Right? Linked list should be list. Sorry. Linked list should also is also in java.util package. Okay, these are the common points that you can make it out by looking at this diagram. Yes or no? These are common points. Okay, now the question is, okay, ideally there should be a question in your mind. Why one has to supposed to go for linked list? Okay, we have already a good data structure. We have an array list. Array list is very much flexible compared to Java arrays. Array list is already flexible. You are able to add data, you are able to remove data, and you can do a set of manipulation by using all these methods. Okay, we have a method like last index of method. Okay, and we have an index of method, we have isEmpty method, we have get method. So many methods are there where you can do the data manipulation. Then why you have to go for array list? Why why you need to go for linked list? Okay, the answer to this question is there are some disadvantages in the array list. Disadvantages are there in the array list. Okay, if you ask me what are the disadvantages that we have in the array list, okay, there are three disadvantages that I can point it out. Okay, let us understand each and everything. Okay, so let me go back to the paint screen. Okay, don't you think that, okay, every system, every computer, every laptop, okay, and every electronic devices, they have the concept of what? RAM. RAM is a storage area where you can store the data temporarily. Yes or no? Yes or no? So when you are working with the array list, okay, Java is going to take care of the memory allocation. We know these things already. Java will come, the language is going to take care of what? It is going to take care of the memory allocation. Let us understand that this is the small piece of RAM that I have in the system. Okay, this is a small piece of RAM that I have in the system. Okay, and each and every block is representing a memory space. Each and every block is representing what? And memory space. Okay, so what do we have studied so far? Okay, if you want to store the data by using Java variables, the memory gets allocated randomly. Okay, for example, let us say that I have a data, I have a raw data like a numerical data. Okay, let us say that I also have a raw data like Java. Let us say that I have another raw data like 100.20, some raw data like a character. Okay, some other raw data like what we call it as the Boolean value. Okay, so these are the raw data. Okay, if I want to store this raw data individually, I can make use of variables. So the data gets allocated randomly. Okay, for the 1 2 3 it may get allocated here. Okay, and for Java it may get allocated here, and for 100.20 it may get allocated here, or for the character D it may get allocated here. Okay, there is no question about, you cannot decide which memory space needs to get allocated for this particular data. That is not in your control. This will be taken care by the language. So randomly the data will be allocated for the variables, right? And this is how it gets allocated. Okay, but when you go for array list or arrays, okay, when you go for array list or when you go for arrays, if I have to create an object for the array list, don't ask me what is array list. We have discussed these things in the in the last two sessions in integer. Okay, obj equal to new array list. So I have said that, right? I have clearly told you, whenever you are creating an object for the array list, okay, this array list is going to accept what? It is going to expect the contiguous memory allocation. By default the capacity is always 10. Yes or no? By default it is going to expect 10 spaces of memory in the continuous way. Okay, so if my RAM size is limited to this space, okay, I have a small piece of RAM and it is few sets of memory spaces, but this array list is going to expect the continuous memory space. It is expecting a memory that is continuous. It expects 10 contiguous spaces. Is there any 10 contiguous spaces in my small RAM? Just imagine that my RAM is very small RAM. Okay, smallest RAM in the world. By using this smallest RAM, I want to store what? I want to create an object for the array list. Ideally, this array list will expect the 10 contiguous memory allocation. Is there anywhere that you can find this 10 continuous space? Okay, if the Java is taking care of the memory, okay, it will try to consider this space 1 2 3 4 5 6 7 8 9. Only 9 is available because my RAM, the size of my RAM is very small. There is nowhere that I can allocate the space for my particular object. Yes or no? So contiguous memory allocation is not possible, because when you use array list, it is always going to expect a memory in the continuous form. Okay, so my RAM is limited in such a way that if you have a small piece of RAM, in general guys, just try to think like this. Okay, so this is for our imagination. If you get usually the RAM is in the size of 1 GB, 2 GB. You will be having a lot of space. will be having a lot of space. Just imagine that if you are overloading the space in such a way that you don't have any continuous space to allocate this array list, okay, then there is a problem. Can I consider this as a disadvantage? Okay, because the disadvantage is array list expects the contiguous. Contiguous is nothing but continuous. Okay, in Java you call it as contiguous memory allocation. Okay, it has to be considered as a drawback. Even though Java is going to take care of this continuous memory allocation, by looking at the RAM, it has some algorithms inside, and it is going to decide which is there any contiguous memory allocation in the given RAM or not. It is going to decide that. Okay, so it is going to decide, but sometimes at times it may not find the contiguous space. So that is a disadvantage. Okay, that is going to be a problem. We will get a memory out of memory error. We will get an out of memory error. Right, so this is one of the disadvantages. Okay, to overcome this, let me write this here. Array list expects the contiguous memory allocation and it is considered as a disadvantage. Okay, to overcome this, one has to go for linked list data structure. Okay, this is one of the disadvantages. Okay, it doesn't mean that it has only one disadvantages. This is one of the disadvantages. Right, so what is the second disadvantage that we have? Okay, second is for disadvantage. Okay, to overcome this, right? The second is for now focus here. So if I want to let us say that if I have a kind of array list, okay, let me create an array list, and what I want to do after creating, okay, I want to store integers. Okay, let me take integer, then I'm creating an object for the same array list. Okay, so an object gets created. It is going to expect what default size of 10. The 10 spaces, continuous spaces will be expected by this array list. Yes or no? Continuous spaces, no issues. Now let us consider that my size of the RAM is doubled. Okay, to understand this, let us consider that the size of the RAM, the size of my current RAM, okay, is going to be doubled. Okay, where is the RAM? Okay, here we have the RAM. Okay, so to overcome this, I am able to overcome this issue by increasing my RAM capacity. No problem, I can increase my RAM capacity, isn't it? I have an option to, I can purchase my RAM, or I can I can do some modification where my RAM size capacity is going to be doubled. I can do that, right? So my RAM is doubled. So we have solved this problem. Okay, now I have created what? I have created an object. Okay, so this is going to do what it is going to do? Okay, it will allocate 10 spaces of memory. It should be continuous. Randomly, Java language is going to take care. Okay, you do not have to worry about the spaces. Java will communicate with the RAM internally with the algorithms, and any 10 blocks. Okay, it can start from where, anywhere, randomly it could be chosen. You don't have control on this. Okay, so 1 2 3 4 5 6 7 8 9 10. Okay, so let us assume that okay, this memory has been blocked or allocated for this particular obj. So this is talking about what? Capacity. So far things are going good. Right? How many spaces are? 1 2 3 4 5 6 7 8 9 10. Okay, let me remove this, guys. So ideally it should be 10, isn't it? Yeah, so we got, okay, the capacity 10, and it is going to have what? It is going to have the obj as a reference variable, address reference. So far things are good. Now I want to add 5 elements. So we are talking about the drawbacks of the array list. Okay, focus here. I want to add how many elements? I want to add 5 elements. To understand the disadvantage, I'm just adding the 5 elements. Okay, these 5 elements will be added. I will be taking any values, no matter. We do not have to focus on the values. We need to focus on the data structure. Okay, the first one is 1, second one is 2. I'm keeping it very simple for the understanding. And third value is 3, and the fourth value is 4, and the fifth value is 5. Right? So according to, it is going to preserve the insertion order. Okay, according to this order, the these values will be added, right? So okay, let me go back to the paint screen once again. Okay, should I copy this? Let me copy this. You know, see the disadvantage here. Okay, we have a big disadvantage here. Okay, these are the values that I want to add in this reference variable, right? Okay, so now what happens according to this? Okay, I can say that the value 1 will be added here. Okay, and 2 is going to get added here, and 3 is going to get added here, and 4 is going to get added here, and 5 is going to get added here. So I'm sorry, this is 5. Okay, so far we have no issues, and according to the values that we have added, okay, the respective index number will be generated. Index number always starts from 0, 1, 2, 3, and 4. So far no issues. Okay, now I want to do what? I want to add a value on top of the 0th index. I want to add a value on top of the 0th index. Okay, if I do that, there is a problem. Okay, we don't see that problem visibly. We can't see that problem, but internally some problem is happening. Not a problem, a lot of work is happening behind the scenes. Okay, let me do this. Obj dot, I want to add, I want to choose an index. On the 0th index, I want to add an element like 1000. Okay, we have discussed about this method yesterday. Okay, this is the add method, overloaded add method, that is going to accept 2 parameters. The first parameter talks about the index specification, and the second parameter is talking about the value that you want to add. Okay, so this says you want to add the value 1000 on the 0th index. Okay, so I am doing what? I want to do this. Okay, I want to do this. This is going to produce a lot of heat in the RAM. Okay, when I say a lot of heat, when I say a lot of the heat, what does it mean? A lot of things that are happening behind the scenes. What are the things that are happening behind the scenes? That is a point of discussion. Okay, so this is the line. Okay, so ideally we are able to see, okay, this is the line that I want to add. Okay, so when I run this code, okay, before adding I want to print this obj. After adding I want to print this, as well as before adding I want to print this. Now see, before adding we have how many elements? 1, 2, 3, 4, 5. Okay, let me remove this code. Let me run this. Okay, so I am able to see 1, 2, 3, 4, 5. Okay, now I want to add what? On the 0th index I want to add the value 1000. When I do this after adding, okay, this is how the information in the console is going to look like. Yes, isn't it? So 1000 is added and 1 has been, so see, this is the output that we got. Okay, internally what is happening? You can say that, sir, by just in a matter of nanoseconds or microseconds the output has come out. Yes, the output is very fast. According to humans, the output, as we are witnessing the output, you know, in a faster way. But internally, even though the output is very fast, internally what is happening? Because of this line, just because of this line, okay, so we are choosing 1000 to be added in the, okay, on the 0th index. On the 0th index I want to do what? I want to add the 1000 value. Okay, so you should create some space. Internally the array list is designed in such a way that this value cannot be erased. This value will be there intact. Okay, this value has to be moved somewhere. It will not be deleted. Okay, now what will happen? So to add 1000, this 1 has to be moved. Okay, so this 1 will be shifted to the first index. So to shift the 1 to the first index, okay, there is already a value 2. This needs to be shifted. So this needs to be shifted here, this needs to be shifted here, and this needs to be shifted here. See how many shifting are happening in the worst case. Okay, so this 5 has to shift here to give space for 4. This 4 has to shift here to give space for 3. This 3 needs to get shifted. Yes or no? To give space for 2. This 2 needs to be shifted to give space for 1. Okay, at last the 1 needs to be shifted to give space for what? The value 1000. So 1000 will be added. Okay, 1000 is not getting added just like that. It is not just like that. Addition is not happening. Okay, the information is not getting manipulated just like that. Lot of shifting is happening. Okay, if you talk about the worst case, it requires, okay, n number of shifting is required to add one element at the 0th index. It requires n number of shiftings to its right side. A number of shiftings to this right side, where n is the size of the array. Okay, if the size of the array is 5, it requires 5 shiftings, right? So let us say that if the size of the array is something like 10,000. Okay, so if the size of the array is 10,000, to add one element, the system has to go through, do what? It has to do a lot of work. It has to do 10,000 amount of shifting. The size of the array is something like 100,000. Okay, if you want to add the one element, if you want to add an element in the 0th index, it requires this many shiftings. Okay, the size of the array is 1 crore. Okay, to add one element on the 0th index, it requires this many number of shiftings. So don't you think that this is the biggest drawback that we are? So inserting an element is a drawback. Yes or no? I can conclude that. So when you are inserting an element in an array at the specific index, okay, so in the worst case, the first index or the 0th index, it requires how many shiftings? The size of the array shiftings. Plus n number of shiftings, where n is the size of the array. So can we take this as a drawback? Okay, this is a biggest drawback, right? So visually, so you are just visualizing this on just one click, you are able to see the output. Okay, so you are able to see the output just like that, but behind the scenes this many things are happening. Likewise, if I am adding one element, I am getting this problem. Likewise, if I want to remove one element, okay, if I add to remove one element, okay, let us say that I want to remove the same element. After adding, I want to remove what? I want to remove the same element. Okay, I am specifying the index as 0. Now this time, what I am trying to do, I am trying to remove the element on the 0th index. Okay, we have just added and we have seen what is happening behind the scenes. Now I want to remove it. After removing it, what is happening behind the scenes, that we can understand now. Okay, what will happen behind the scenes after removing these things? Okay, so this is the line. Focus on this line. Focus on this instruction. Okay, you are giving an instruction to the system to remove an element on the specific index. What is the index that you have specified? Okay, the index number is 0. You are saying remove the element that is on the index 0. Okay, so ideally this is the 0th index. Okay, this 1000 is going to be what? Removed. Okay, as soon as this is removed, a void space is created. Okay, the array list usually they don't accept the void space. Right? Whenever a space is getting created, okay, that space needs to be filled by the next element or the next value that is on the index, that is on the next index. It will be shifted here. okay, and there is a void again, okay, it will be what, it will be shifted back to the same place which it was, where the void has been created, where the space has been created. Okay, shifting, okay, shifting, okay, and again shifting. Okay, so there is a problem in deleting an element. Okay, after shifting, the index number 6 will not be there. Okay, so we need to remove this index number 6, because only when value is there, okay, there is the scope for the indexes. When there is no value, index numbers will not be generated. The generated, already generated index number will be deleted. Okay, and again it has shifted back, each and every element has shifted back. Okay, adding an element is also a problem, and also removing an element is also a problem, because lot of shifting is taken care. Okay, this is also one of the disadvantage. Can we conclude? Are you able to understand the disadvantages? Okay, so we are going to overcome all disadvantages by using the linked list. Okay, what can I say? When you are deleting an element in array list at a specific index, in the worst case the 0th index, it requires the n number of shifting, where n is the size of the array. Okay, the shifting happens towards the left. The shifting happens towards the left direction. Okay, and I can copy these, I can paste it here. So I need to change only one word. The shifting happens towards the right direction. So when you insert, the shifting happens towards the right direction. When you delete, the shifting happens towards the left direction. Right, this is the point number 3. Okay, when someone is asking you, okay, you have a lot of points to talk about array list. Okay, when they ask you specifically about the disadvantages, you should be in a position to answer these 3 points. What is this? Not interesting. I am bad at spelling, guys. Okay, don't please apologize. Inserting, okay, inserting an element, deleting an element. Okay, so to overcome this, please be informed that to overcome the above 3 disadvantages, right, we go for linked list. Disadvantages. Okay, tell me, type in the chat box, are we good so far? Are we good to proceed with the linked list? Yes, no? Everyone type yes. I want to ensure that you people are staying active along with me. Keep this chat session interactive, right? So we are good to proceed. So now let's talk about the linked list data structure. Okay, so this is a very interesting data structure, guys. People are the people who have designed this, we need to appreciate them. Not a simple appreciation is required, because look at the way that they have analyzed and they have come up with the solutions to overcome the disadvantages. Okay, let us see each and everything. Okay, so why linked list to overcome this. Okay, then what is a linked list? Question, what is a linked list? Okay, so that I am going to take a new RAM. Okay, so let us take the small RAM. Okay, so we are not affordable to purchase a very big RAM. Okay, we are affordable to purchase only a small RAM. So this is our actual RAM. Okay, so by using a linked list, so in the array list, the data structure says that the memory allocation is contiguous. Yes or no? In the array list, the data structure is saying that the memory allocation is contiguous, and there is a default value, there is a default capacity. Okay, let me put this in the code. So when I just have this line, ideally my RAM will be occupied. My RAM is going to have 10 continuous sets of memory is going to get occupied. Yes or no? Because array list default capacity is 10. Okay, so this line is going to do what? It is going to consume 10 continuous memory spaces, right? But when I use the linked list is a class. Okay, when I use a linked list data structure and I want to store integer, okay, and I want to do what? I want to store the linked list. Okay, so what is the default capacity of the linked list? Any guesses? Can you guess? Is there any default capacity? You can just ArrayList as default capacity of 10. Do you think that the linked list is going to have the same capacity, or it is going to have different capacity? Just a guess, guys. Any answers? Don't know. The answer can be don't know. The answer can be 10. Not sure. You have to answer something, no? You cannot stay ideal just like that. Don't know, sir. Good. Right, let's appreciate Ratna. Somewhat you need to answer if you know or if you don't know, whatever it is, you should respond, no? Okay, Ratna says don't know. I am assuming that everyone don't know. Okay, so there is no concept of default capacity. Okay, so this particular instruction is not going to make any changes in the RAM. Let me repeat. Okay, this particular instruction, okay, when I add this instruction in my code, in the RAM, no space will be consumed. So when I say no space is going to get consumed, it is like there is no concept of default capacity in the linked list. There is no concept of what? No concept of default capacity in the link. In the array list, the default capacity is 10. Whereas in the linked list, okay, there is no concept of default capacity in this linked list. Concept of default capacity in the linked list. Okay, if there is no concept of default capacity in the linked list, okay, this is one of the differences. Okay, how it is going to overcome the disadvantages? That should be our next question, valid question, isn't it? Okay, so let us add 4 elements here, and we see the output. From the output, we will come to conclusion. Let me remove this. So now we are dealing with the linked list. Okay, my class name is linked list. It's a generic type, so integer. So I will be saving only the integer values. Okay, obj.1 add. I just want to add 4 elements, guys. Okay, I want to add 10, and I want to add 20, and I want to add 30. I mean 20. This is going to be 20, and this is 30, and this is going to be what? This is going to be 40. Okay, so when I do system.out.println, I want to see the values that is getting displayed in the console. Okay, values are 10, 20, 30, 40. Okay, insertion order is preserved. I can come to a conclusion that insertion order is preserved. Okay, 6th point. The insertion order is preserved. Okay, still it is not answering the disadvantages. I will answer you that. Preserved in the linked list. When I say insertion order is preserved, it means the insertion order is maintained. It is not getting violated. The elements are ordered, added in this order. Okay, the elements are getting displayed on the console in the same order. So that's why the insertion order is preserved. Okay, what is happening behind the scenes? When you do this, what is exactly happening behind the scenes? That is the question. Okay, you are doing what? You are adding 4 elements. Okay, now you see, just focus here, how these values will be added in the RAM. How this data will be stored inside the RAM, that is the question. Okay, so this data is going to get stored randomly. Okay, language will take care. Okay, the program is using linked list and is adding the first value as 10. The language will take care in such a way that the 10 will be allocated somewhere in this memory space. What is this next value? Next value is 20. It will be allocated somewhere in the memory space randomly. 30. Next value is what? 30. Let us say that 30 is getting allocated here. Let us say that 40 is getting allocated here. Focus here. Focus here. So far, good. So far, the allocation is what in the it is getting allocated randomly. Okay, so as soon as the values are getting allocated randomly, let us say that this value, this memory space, okay, focus here, this memory space as an address A. For the imagination purpose, I am saying memory space as an address A. To keep some differentiation, I am taking it as what? Small a. Okay, this block of memory is representing an address which is small a. So each and every city is going to have a pin code, right? Chennai as a Villivakam as a pin code, and the Ainavaram as a pin code. Okay, every city, every say city inside the city has some pin codes. Likewise, the address references are there for the every object references. Right? So A, let us consider this as B, let us consider this as C, let us consider this as D. Okay, so what it is going to do, the moment you add the first element, okay, the first element gets added randomly. Okay, so as soon as you added the second element, okay, so it is going to create a node. Okay, this first element is going to occupy the next space, next empty space. Next empty space will be occupied, and the address of the second element will be stored here. The address of the next element is what? 20 is the second element. This address is B, that will be stored next to the first element. Okay, let me keep it very slow. Now you have added what? You have added the second element. You have added what? You have added the second element. Second element is 20, successfully added. Right? So after adding the second element, there is a third element which is 30. Okay, the address of the third element will be stored next to the second element. Okay, now you have added third element. Third element is going to store the address of the fourth element, which is what? D. Okay, so far the things are smooth. So far the things are smooth. Okay, fourth element. Fourth element has no address because there is no more elements added after the fourth element. Okay, obviously the address is going to be what? Null or empty. Empty means in Java, when something is empty, the null is going to be used in the empty spaces, the value null. When you say value null, when you see the value null, that means that is the last element. Okay, good. We have 4 elements. Right, now what has happened? Okay, so this part is what? This part signifies the first element. Let me take that, let me separate it. Right, and this part signifies the second element. Let me separate this. Okay, and this part signifies the third element. Let me separate this. And this part signifies what? The last element, this fourth element in our case. Let me separate this. Okay, so the now if you look at, there are two memory spaces. Okay, this is the memory space that is actually storing the data. This is storing the data. The second memory space is storing the address of the next value, next reference. Right? Data and the address of the next reference. Data and the address of the next reference. Data and the address of the next reference. Since there is no next reference, it is null. Right? Ideally, what will happen? Okay, the combination of the data and the address. The combination of the data and this address. Okay, this part especially, it is called as the node. What is it? We call it as what? Node. Okay, get acquainted to these words. Okay, this part is called as what? Node. When I say node, in this context, what does it really mean? Node is the combination of value and the combination of the address, not the current address, the next address, the value of the next address. Okay, since this first node is storing a value 10 and also it is storing the address of the next value B. Look at this. Okay, the address of 10 is A, address of 20 is B. Okay, so the next space is utilized to store the address of the next value. So a link is happening here. What is happening here? A link is getting happen. Okay, since C is the address of the next value, a link is happening. D is the address of the next value, a link is happening. Okay, so we have how many links? We have 3 links. Right? So what has just happened? A link is happening. So data is getting allocated randomly. Okay, first value is getting added here, second value. So here you observe one thing. Okay, the memory is not getting allocated continuously. Randomly, wherever the spaces are there, even though if your size of the RAM is very small, it will utilize the random spaces and memory gets allocated, and the sequence will be maintained by these addresses. Okay, it is being linked by these addresses. Right, it is being by linked. I am saying what? Linked. Let me iterate. Linked. That's why it is called as what? The linked list. Okay, so null is going to give you the last data and the first data. Okay, there is a concept called the head. Okay, so a default head will be created. We call this as what? Head. Okay, this head is going to store the reference of the first value a. Okay, now you see the beauty of this concept. Okay, still. Okay, so what is the first? We have overcome the first advantage. Okay, what was the first disadvantage that we had with ArrayList? ArrayList expects the continuous memory allocation, right? This is a disadvantage. But LinkedList is not expecting continuous, right? The values are getting stored randomly. First value has been stored here, second value has been stored somewhere here. Okay, system Java language is going to take care where it needs to be stored. Even if you have the small piece of RAM, okay, the most of the memory is getting utilized, right? So the value is stored as well as the next space is going to be utilized to capture the address of the next value, so that a link is created. And we call the combination of the data and combination of the address as a node. When I say node, node means what? The combination of the data and the address of the next data. Okay, if you want to fetch the value of the first, first index or the first value, okay, a default node will be created. This default node is going to store the address of the first value a. Okay, when you don't have any values after adding the last value, okay, you place it as null. Okay, now if you want to insert an element, okay, so let us say that, okay, let us go back to this code. Okay, so we call this as linked list because it is linking each and every memory blocks, and each and every node is getting linked to one another according to the data that we are adding, right? So this is also called as what? Singly linked list. Singly linked list. Keep it. We will park this concept here. Okay, singly linked list. Why it is singly linked list? What it has to do with the linked list data structure? We will understand that. For now, this data structure is called singly linked list. Right? What are the advantages that we have with the singly linked list? And there is one disadvantage we have in the singly linked list. We will understand that. If I want to add an element, let's go back to the code. Okay, and after printing this, okay, I want to add something like on the zeroth index, okay, on the first index, or is there any add first? Let me take. Okay, there is a method called don't think about this method. We have a method called what? Add first. Okay, and I want to print after adding this, I want to print the same data structure. Okay, now see what is happening. I'm using a method called add first. What does it mean? I want to add 1000 on the first index, right? So what is happening? So previously we had to do what? A lot of shifting is happening to add an element. Okay, now you see the beauty of the linked list. Whenever you're adding an element, okay, so this is the instruction that you want to give. Okay, add first 1000. Add first 1000, right? So what happens? Okay, a kind of node will be created. Okay, node is going to have node is going to get divided into two parts. First part is for value 1000, right? The second part is for what? Address. Okay, address. Second part is reserved for address. Okay, we are adding what? We are adding the value 1000 by using the add first method. Okay, this add first method is going to capture. It is going to capture the address of the head. Is going to capture the address of the head. Okay, address of the head will be captured here, right? And this will be moved. Okay, this will be placed here, right? And this head is going to store the address of the newly added element. Let us assume this as Z. No shifting is happening. Everything's are in place. Okay, let me repeat this by using this. Let us don't touch this. You may get a kind of confusion. Okay, So I'm doing what I'm doing, add first. By using the add first method, I want to add something like 1000. Okay, so in the RAM, somewhere randomly 1000 will be added, and this is going to have, it is going to, what we are doing, we are adding it to the first element, right? Add first. Okay, so add first means this, already the element that is already added is 10 is what being displayed as the first element. Okay, so it will expect this address. Okay, this 10 is stored on the address A. So now 10 is stored on the address A. Okay, now this will get address A. Okay, this is going to form a node. This is going to do what? This is going to form a kind of node. A node is a combination of the value and the address. Okay, and this will be formed like this, right? And again, this 1000 is going to have a physical address, something like, let us take as an example Z, something like Z. Okay, now this 8 will be moved here, right? And this A will be replaced as Z. Okay, now 8 becomes Z because that is the first element. Okay, so this is going to occupy this space. So what I'm trying to say is, no shifting is happening. A link is getting broken, and this is what, only the head is, if you replace the head, only the change is on the head. Okay, no shifting is happening. You are just changing the head. Okay, and this head is getting the add first value reference, add first value address. Okay, and the value is getting what, the previous address of the first value. Yeah, right. So what I'm trying to say is, insertion, when you insert something in the beginning, no shifting is taking place. It is getting added very easily. Just this head is getting changed. That's it. Just focus on this head. This head is just getting changed, and you are able to add the element easy. Your link is getting broken, and it link is getting unbroken once again. Right. Likewise, when you want to delete an element, delete the first element. Okay, when you are when you are happen to delete the first element, obj1 dot what can I say, remove first. Okay, after removing the first element, I want to print the data structure once again. Okay, we got the same value, so we have the first okay, this is going to print the actual data 10 20 30 40. After this you are adding 1000, so the data structure has some changes. 1000 is getting added, but here the shifting is not happening. Okay, and again I'm deleting the first element, so these are the things that is happening behind the scenes. Again we are able to see 10 20 30 40 because 1000 first element is getting deleted. Okay, when you do the delete also, specifically you want to delete the first element. Okay, so this will be removed, that's it. This part will be removed. Okay, and this head will be connected. Okay, and instead of Z, it is going to store the address of A. Okay, no shifting is there, no concept of shifting is there. If you get any kind of doubts, just repeat this video with a pen and paper, because node is a confusing part. Okay, capture address. Okay, give any kind of own address, right? It can be in the numerical form. For the imagination, you can place the own numbers in the numerical form or in the alphabetical form, no issues, right? So what I'm trying to say is, no shifting is happening. This head is doing all kind of work. Okay, if you want to add one element in the first, this is giving some space, and the element is getting added. No shifting is happening. If you want to delete one element, okay, this is getting removed, and it is going back to its previous position. Okay, so adding an element, and deleting an element is easy by using linked list. Okay, so far we have discussed about what we have just discussed about the singly linked list. Okay, this topic is dealing with singly linked list, single linked list. But the topic that we are discussing is, okay, now see the now what we call it as, now see the twist. The linked list internally using doubly linked list data structure. So far you discussed about singly linked list, but the linked list is internally using not singly linked list. It is internally using doubly linked list data structure. To understand this doubly linked list data structure, first of all, you need to understand the singly linked list. Okay, by the singly linked list, you can easily add an element and you can easily delete an element when it is the first element. If you want to add an element in the first index or in the zeroth index, it is easy by using singly linked list. But if you want to delete an element by using the by using the same singly linked list, it is easy to delete an element. Okay, but when you want to add an element in the last index, okay, when you want to traverse and when you want to find an element of the last index, this is going to be very difficult. Just to start from the beginning, okay, it needs to take n number of iterations. Okay, this part we will understand tomorrow. Okay, so tomorrow you will understand the concept of doubly linked list. Okay, so this doubly linked list is the internal data structure of the linked list in collection frameworks. Okay, just a quick recap. Just a quick recap. So we have completed this array list and we are talking about linked list. Okay, so to overcome the drawbacks of array list, so we are going for what? Linked list. Okay, what are the drawbacks that we have with the array list? Okay, these are the three drawbacks. Okay, memory space will be contiguous. Okay, that has been already addressed. Shifting takes a lot of time, addressed. Deleting takes a lot of time, that is also addressed. But we have addressed based upon adding the element by considering the first index or the zeroth index. Right? Tomorrow we will understand what is doubly linked list and what is the significance of the doubly linked list. Okay, so that all these things, this stack, this vector are going to be very easy to be completed. Right? Any questions for me? Yes, no? If you are feeling what we call it as